Okay, guys, so this is phase 5 of cycle L. And there's only 2 more after this. So, okay, and both the 2 more after this are more like review than anything. So this is the very last like new thing, and it's not even that new. You'll see. So we're given a differential equation. We saw differential equations in the last phase with slope fields. Every differential equation has a slope field, which is like those little line segments that indicate the slope at each point that the differential equation gives. But also, guys, if you're given a differential equation, you can find the original function. Okay, now a differential equation is kind of, if you look back at our, if you look back at that huge document that I sent you at the beginning of all of this, the quarantine stuff, where I compiled like everything we'd done for the year that far, there was a implicit differentiation. That's the stuff where you did like, y prime after y, and what we did when we did implicit differentiation, we basically ended up, our answer was a differential equation. Okay, when you do implicit differentiation, your answer is a differential equation. So if you do implicit differentiation to get this, then there must be a way to reverse it and end up getting like the original equation. So that's what we're going to be doing. So we're going to take a differential equation and we're going to reverse the differentiation that was done to achieve it. And then that's going to give us like the original equation. So this is anti-differentiation basically. But instead of just having one variable, we have some variables mixed together. So you'll find this really, really simple, I think. And if you don't, please text me or reach out to me and I'll help you. So given the differential equation right here, find the particular solution y equals f of x with this initial condition. So I'll show you how to use that later. But here's the thing, guys. If they say find the particular solution y equals f of x like this means solve for y. Here they're telling you how they want the answer expressed. They want y to be solved for. Okay, that's what that means. And I'll tell you how this comes into play later. Okay, so basically, guys, since the x's and y's are mixed together, here we have dy dx equals x squared minus 3 over 2y. We've got a y and an x on the left. That's just part of the notation. But we've got x's and y's on the right of the equal sign. We want to separate them. We want the y's on the left and we want the x's on the right. And the way to do this is to cross multiply. Okay, so if you cross multiply this, guys, the 2y comes up over here in front of the dy. And the dx comes up over here at the end of the x squared minus 3. So this bottom goes up there, this bottom goes up there. So here we're cross multiplying, dot, dot, dot. So we end up with 2y dy equals x squared minus 3 dx. Important that the dy and the dx are at the ends, because I'll show you why in a minute. Guys, so a derivative was taken to get this differential equation. So how are we going to reverse that process? We're going to do the antiderivative, which is an integral. So once you do this, then you put integral signs on the front just like that. All right. And if we had x's and y's mixed, we could not take the antiderivative. But since this is completely in terms of y, we can take it. Since this is completely in terms of x, we can take the antiderivative. Okay, so antiderivative. So this is going to be 2 over 2y squared. Don't do a plus c. Okay, there is no need for a plus c on the left. We're going to put it on the right, and that will take care of the whole family. The plus c at the end will take care of the whole family of antiderivatives. You don't need to have it on both sides. Okay, and then here, this is a third x to the third minus 3x plus c. Remember, when you're doing an antiderivative, you're finding a whole entire family, and that's what this plus c at the end indicates. Okay, it wouldn't be wrong to have a plus c here, but it just complicates things. This one at the end takes care of all the possible members of the family that this could be. Okay, so let me simplify this a little bit. So this is y squared equals a third x to the third minus 3x plus c. Now, guys, if they're giving you an initial condition, that means that they want you to find c. Okay, use to find c. So we're going to use that to find c. So we're going to plug, because they want for our solution to be correct, it needs to be the case that f of 3 equals 5. Okay, that an x value of 3 corresponds to a y value of 5. That's only going to be true for a certain value of c. So to find that value of c, we're going to plug 3 in for x, 5 in for y right here. Okay, so this ends up being 5 squared equals a third, 3 to the third. This is 25. That ends up being 0 plus c. So c is 25, all right? C is 25. So that means that I'm going to take this, and I'm just going to put 25 in for c. So this is y squared equals minus 3x plus 25. Okay, now you would get partial credit if you stopped here. For sure you get partial credit. You get credit for finding the you would get credit, let me tell you, for separating the variables. Okay, so just for doing the separation, the cross multiplication, you'd get credit. For doing the antiderivatives correctly with the plus c, you get more credit. For finding the c, I think you get credit for that. So I think you get like substantial credit right up to here, but we're not done because they want the particular solution y equals f of x means to solve for y. So I want this y by itself, so I take the square root of both sides. And remember, when you take the square root of both sides of something, you do plus or minus. But then, guys, you have to go back to the initial condition. So it can't be both. Or the answer is not going to be plus and minus. It's either got to be the plus version or the minus version. And so we look at our initial condition. We want f of 3 to be positive 5, all right? We want f of 3 to be positive 5. And you might already see this, but so yeah, so guys, in order for that to happen, is it going to be the plus or the minus version? Well, actually, you don't even need to do that. I was going to plug 5 in for all the x's. I guess I'll do it. So that's a third, no, 3 in for all the x's. A third, 3 to the third. Oh, shoot. I forgot the square root, but that's 25, and then I'd have to take the square root of it. So this ends up being, so underneath the square root, the whole square root part does end up being 5, but do I want a plus or minus out front? I want the plus because I want this to be positive 5. So since we want f of 3 to be positive 5, it's the plus version. Okay, so that's the answer. Okay, let's do another one. And I think, again, I might have said to do 5 of these maybe, but I think you'll find them not super hard. So again, given this differential equation, find the particular solution y equals f of x with this initial condition this time. So same as before, we want to cross multiply. We want this 3y to be over here with the dy. We want the dx to be up over here with the x plus 3, so you cross multiply. So this is 3y dy, x plus 3 dx. So you have separated the variables. just y's, just x's. Now we do the integral on both sides, which is an antiderivative. This ends up being 3/2 y squared equals 1/2 x squared plus c. Now we're going to use the initial condition to find that c. So in for x is -6, in for y is -4. So 3/2. Okay, and this ends up being 24. Okay, so c ends up being 24 there. All right, so we've got 3/2 y squared. Okay, guys, you've got your majority of your points here, but now we need to solve for y. So I'm going to divide both sides by 3/2. All right, so those will cancel. And guys, dividing by 3/2, keep, change, flip, right? Keep, change, flip if you're dividing by a fraction. So dividing by 3/2 is the same as multiplying by 2/3. Now, even if that is sort of a challenge for you, if you're not confident with doing that, you could use your calculator. You know, you could do 1/2 divided by 3/2. It would have to be in parentheses though, the 3/2. But anyway, you end up with I gotta do this right. So 1/2 divided by 3/2 is 1/3. So this is 1/3 x squared plus 2x plus 16. And then we got to get y by itself. So y is plus or minus. Okay. But guys, since we've got f of -6 is -4, if we want a negative output, when you plug -6 into these x's and then take the square root, you're going to get for sure a positive number because the square root of anything is, you know, positive. So we're going to need the negative to be there because we want this to be -4. So y equals negative radical 3rd x squared plus 2x plus 16. Guys, we just have 2 more phases for the whole entire year. And they're really not bad. And they're going to tie together a lot of good things. And yeah, I would say just make sure that you're writing things down that you want to have in front of you for your test that is coming up. All right, I'll talk to you later. Bye-bye.